Hello, my name is Ryan Lubke. I'm a member of the Coherence development team. Today I'd like to discuss the integration of open tracing in Coherence 14.1.1. Today's agenda is simple: an overview of the feature, various ways to configure the feature, and of course, the aforementioned demo. Open tracing is a vendor-neutral API for distributed tracing, perfect for providing insight into distributed software systems such as Coherence. Coherence currently only interoperates with Open Tracing API versions 0320 and 0330. Any compatible vendor implementation may be used, however, it must be bootstrapped by a tracer resolver implementation, which is another open tracing library. This library allows discovery and initialization of the runtime using Java's service loader. Please note that at this time, we're only aware of Jaeger including an implementation of this API, but it's simple enough to implement and expose any open tracing compliant runtime. And lastly, we'd like to note that Coherence does not ship with any particular open tracing vendor. What operations are traced? Currently, name cache operations when using distributed caches, events generated for map listeners and event interceptors, cache store and persistence operations. The performance kit considerations, and please note this was a very simple performance analysis with about 8 cluster members. We observed about less than 1% impact on performance when tracing was disabled, and observed about a 5% impact when it was enabled. And during this test, we were, of course, using Jaeger. 3 ways to configure. The first is through the operational override file. You simply specify the trace and config and the sampling ratio, and we'll discuss the actual meaning of the values for the ratio on the next slide. The next method is a system property, the Coherence tracing ratio system property. And lastly, you can configure tracing dynamically via JMX. You can configure tracing on a per node basis by changing the tracing sampling ratio property on the desired node MBean, or you can enable it cluster-wide using the configure tracing operation on the cluster MBean. So valid configuration values, -1, this value will disable tracing, and this is the default. 0 is kind of a special case. This means Coherence will not initiate tracing spans on its own. Therefore, a tracing span must already be active. Otherwise, Coherence will drop the span. And then lastly, a range of between 0.01 and 1.0. This is basically a percentage of spans that will be captured. So a value of 0.1 will mean 10% of the spans will be captured, while a value of 1.0 will result in all spans being collected. Let's go ahead and look at a quick demo. Okay, here I have a Coherence distribution that I've installed locally. And I have a couple shell scripts to start the cache servers in the console. If we take a look at the console, we can see what's going on. Here you can see we set the tracing ratio to 1, which means all spans will be captured. We also set the Jaeger service name to Coherence. This can be whatever value you guys wish to use. This is what's going to be displayed in the UI for this particular cluster. And then we also give it the endpoint for the trace captures. And we also here include all the dependencies necessary for Jaeger to operate. And the cache servers are pretty much similar. Again, we pass in the tracing ratio, the service name, and the endpoint. Okay. And I already have a Jaeger instance running in a Docker container, so we should be set to go ahead and start the servers. All right, and we can go ahead and use one of the caches. can insert a value and do an update. Then if we switch over to Jaeger, come back, we can see that we have now a coherent service, and we can go ahead and find the traces that have happened recently. And here we can see a put request. And if we expand this out a bit, here we can see all the different stages that occurred during this put request. We can see that the request was made member 3. It was dispatched and it's being handled by member 2. And then we have the processing of the put request by the same member. And then we also have the backup request for the partition cache. And we can see this is being handled by member 2. Or actually, member 1 after being dispatched from member 2. So why does all this matter? That was a very simplistic demo. But what if we take a more complex approach where we have a demo where we're able to trace the entire server-side stack from JAX-RS to Coherence all the way down into the database? That provides a more compelling story for the feature. Let's go ahead and take a look at this demo. So here we have a modified version of the open source Coherence demos. Aside from the internal tracing changes that we've made, we've also made it possible to dynamically turn tracing on and off using management over rest. So we can enable tracing on each individual member, or we can come up to the tools menu and we can configure tracing, where we can enable it for the cluster, in this case for the demo, even members or odd members. We'll go ahead and enable it for the entire cluster. And we should see an update when the next tick. There we go. And we'll give it a couple more ticks to record the traces. And so if we switch back to Jaeger, we can see that we have the Los Angeles cluster available to peruse. And if we take a look at the traces, let's see here. Here we go. This is one of the JAX-RS requests. And here we can see all the operations that took place to service this particular request. So we can see a couple size requests going out. We can see a utility class being called to update the prices on the view. And you can see in order to do that, we are dispatching an invoke request. And you can see this invoke request is coming from member 1. And it's being handled by member 3. And here it is performing an update. This is a entry processor, Lambda. And here we update the entry, and we see the backup requests going out to back up the updated data. Once that completes, we do a cache store update, which is going through the JPA cache store, followed by an update to the database. And we can see the exact database statement that was executed. If we go back to the demo, I think this gives a pretty good overview of why this feature is useful. It gives you complete visibility into your entire stack, so you can pinpoint where potential issues may lie within the environment. I want to thank you for your time for reviewing this presentation. Take care.